we have a function f which is defined in the interval AB. Defined in the interval AB means that domain of that function is AB, and C is any point in this interval where we want to check its continuity, whether a function is continuous at that point or not. Okay, so there are three possibilities. We'll be checking three possibilities for a point C. First, if C is the anterior point of the interval, that is C is between A and B. Interior means C is neither equal to A nor equal to B. Second condition we'll be checking, that is if C is equal to A, mean to say checking continuity of a function at the left end of the interval. This is the left end. There are three parts for interval: left end, anterior part, and right end. And the third case is, as I explained earlier, if C is the right end of the interval. So we'll be considering these three cases for checking continuity of a function at a specific point. Okay, so we first consider if C is the anterior point. If C is between A and B, and we want to check its continuity at that point. You see, its definition is given here, that is, say a function is continuous at C, where C is any anterior point. Okay, so we take this condition which means limit x goes to C f of x, that should be same as f of C. But this statement is equivalent to three statement. It's not a single statement. It's basically there are three statements. And what are they? The first statement is two quantities can be equal if both of them exist. So we say first one, we check whether f of C exists or not. So we say f of C must be defined and what do we mean by define? Defined means it will not be 0 by 0. Let me call it, it will not be any indeterminate form, not only 0 by 0, any indeterminate form. Indeterminate forms, you know that it is either 0 by 0, it could be infinity by infinity, it might be 0 power infinity, it might be 1 power infinity, it might be infinity minus infinity, etc. Right? So we should say f of C will not be any one of these. And secondly, it will not be only infinity as well. If f of C is either infinity, that is, it could be 1 by 0 or 1 by something or 2 by 0 or 3 by 0 or 4 by 0, anything dividing by 0 will give you infinity. So it shouldn't be the case. F of C must be defined. So whenever you say f of C must be defined, तो ये चीजें इसमें नहीं होनी चाहिए. For example, if you take f of x is equal to sine x by x and somebody asks you what is f of 0? If f of x is equal to sine x by x, and somebody asks you what is f of 0, so if you see, if we put x equal to 0 directly, that will give you what? That will give you 0 by 0. And then you say this value doesn't exist. This value doesn't exist. But if this is cos x, or maybe this is 1, if we have f of x is equal to 1 over x, or maybe 1 over x square, this is 1 over x, and somebody asks you what is f of 0, You would say f of 0 in this case is infinity, and that is because 1 by 0 is infinity. So this is also not defined. And if somebody asks you what is f of 1, so f of 1 is straightforward. It is equal to 1 divided by 1 is equal to 1. So this value is defined. Condition number 2, or whatever, part 2, is I said this equality is in fact consists of 3 parts. The second part is what? Let's call it 2. That limit at this point must exist. Limit x goes to c f of x. We say this limit must exist and defined as well. Now, what do we mean by existence of limit? In that case, you should say left hand limit is equal to right hand limit. LHL should be same as RHL. If they are not same, we say limit at that point doesn't exist. And secondly, if these two limits are same, the limit should not be infinity as well. Either if that they are same, it will not be infinity. The limit should not be infinity as well. If exists but it is infinity, so we say no, it is not satisfying the second condition. And then the third condition is what we have here. We say value in part 1, value in part 1 should be same as value in part 2. If a function is satisfying all these 3 conditions at an interior point C, we say that function is continuous at the given point C. Second case, if C is the left end of the interval, if C is equal to A, C is equal to A, mean to say if it is the left end of the interval. Sometimes we check left hand continuity as well. That's then we call it one-handed continuity. If we have a left end of interval, okay, in that case we come here, you say the function is a right continuous at that point. Then this is the definition for it, and as I said earlier, it is basically equal to 3 again parts. The first one is exactly the same what we had in case of interior point. F of C must exist. That is defined. Condition number 2, instead of whole limit, we check only right hand limit. That is limit x goes to C from right side, f of x must exist and defined. And third case, or third part of the definition is value in 1 and 2 must be same. If any of these conditions are not satisfied, we say the function is discontinuous. Right? We check right hand end of the interval now.
Sir?
Yeah.
सर ये वैल्यू ऑफ 1 इज इक्वल टू 2, इसका क्या मतलब है सर?
तो मतलब है कि जो वैल्यू पार्ट 1 में आती है और जो वैल्यू सेकंड वैल्यू, मतलब एफ ऑफ सी और लिमिट दोनों सेम होनी चाहिए।
मतलब एक से 2 आता है तो
दूसरे
दूसरे
में
से
2
भी
आना
2 आना
चाहिए,
चाहिए।
एग्जैक्टली।
ओके सर।
Right, if you take c equal to b, that is the right end of the interval, so we are here then, and we call it left hand continuous. Okay, and in this case again this is equivalent to 3 part. This is first, it's exactly the same, f of c must exist and it is defined. Second part, you see the difference is coming in the second part. Limit in this case will be left hand limit instead of going for right hand limit. This limit must exist. And third part, anyone has a problem, I said value from here and value from here, they must be same. That's what I'm shortly writing it, 1 is equal to 2. Right? Okay. Now let's conclude this this slide. If we are checking continuity at the interior point, function value must be defined at that point, and we would check limit x goes to c at that point, and the value should be same. While in case of left end, we would find only right hand limit, and for a right end of the interval, we would only find left hand limit. We don't need, you see, in the interior point, at the interior point, you would find both. You would find left hand limit, you would find right hand limit, they should be same. And then that value should be same as f of c. While in case of left end or right end, you would find only one-sided limit. If you are at the left end, you would find right hand limit. And if you are at the right end of the interval, you would find only left hand limit. And they must exist, and that should be same as the value at that point. Then the function will be accordingly one-sided continuous or continuous. Right? So whenever an interval is given, we consider both things. We consider interior point and end points as well. But the end point, we consider only one-sided continuity. Let's do example. We'll be considering obviously 3 type of example for it. One is if we have graph of a function and we want to check its continuity at different point or at various points. And if you have a function defined unit step, mean to say defined by one formula in the whole domain, and how to check whether when a function is a piecewise defined function. Is it clear to everybody? Do you like the way of presentation?
Yes, sir.
Yes, sir.
Okay. Let's move to the next one. That's the example where a graph of a function is given. Okay, you see, in this case, domain of the function is what? F is defined in the interval 0 to 4. Right? You see, from here we started and we are finishing at 4. Nothing is given behind 4 and after 4 and behind 0. So domain of this function is what? It is 0 to 4. We'll be checking whether this function is continuous at different points or not. So how do we do that? You must learn it, because later on you will do some questions yourself. Okay. Let me tell you a general statement about a graph of a function. If there is no break in a graph, like you see in the interval 0 to 1, 1 to 2, right? From here to here, you see, here to here, you see, here to here, here to here. There is no hole, there is no jump in the graph. So we say function is always continuous there. If you draw a graph of a something and there is no hole, there is no jump, we say this function is continuous everywhere in this interval. We don't need to check it everywhere. From here to here, this function will be continuous because there is no jump. Okay, there is no corner. Sometimes we have a corner like that. So we check continuity at this point. Sometimes you may have a hole somewhere like that. Sometimes we may have a jump like this one, and then we go from here. So at these points, the function may or may not be continuous. We discussed that here. So from here, we can conclude that f is continuous f is continuous in this interval, in the open interval 0 to 1. I'm not considering 0 at the moment. It is continuous in the interval 1 to 2. Again, it's an open interval. It is continuous in the interval 2 to 3. It is continuous in the interval 3 to 4. It is continuous 3 to 4. Right? Because as I said earlier, there are straight lines. So, and there is no jump, no hole in it, and no corner or something. So we say this is continuous everywhere. Now we check at the point 0, 1, 2, 3, and 4, whether a function is continuous or not. Let's suppose x is equal to 0. We check continuity at x equal to 0. Keeping in mind x equal to 0 is the left end of the interval. This is the left end. We check continuity here. Right? So what about f of 0, the condition number 1? We would find f of 0 first. So f of 0 is what? In this case, you see, it is defined there. This is f of 0. Okay, this is f of 0. So f of 0 is 1. So I will simply place a tick mark, means yes, it is defined and exists. Then we find in the second condition, we would find right hand limit because we are at the left end of the interval. So we would find right hand limit. Now, what do we mean by right hand limit? Let me write that as limit x goes to 0 from right side f of x and this will be, you would be approaching to 0 from right side. Means what? If I take value here, corresponding value of y is here. The values of x are given on the x-axis. You see that these are the values of x and these are the values of y. So if you take this value here, geometrically, obviously, we don't consider x equal to 0.5 or something. We're simply marking a point here. If you take x this one, the corresponding y is this one. If you take x this one, corresponding y will be this one. If you take x this one, y will be this one. So from here, you can observe that we are approaching to 0 from right side. And the graph is approaching towards which point? The values are going towards 1 on the y-axis. On the x-axis, the values are going towards 0, while on the y-axis, the values are going towards 1. So we say limit of this function is what? That is 1. And then in third condition, you see value obtained in, we don't find left hand limit in this case because we are at the left end of the interval. And it's obvious there is no function defined on the left side of the of 0. Okay, so we don't need to find it, right? Otherwise, you would simply say left hand limit doesn't exist, and then the story is gone. So third part, is f of 0 same is the limit? This one, and the answer is yes. So we say value in 1 and 2 both are same. This is 1 and this is 1. Therefore, f is continuous.
Sir,
जी.
सर ये सेकंड कंडीशन में 1 किस तरह आया है?
Okay. You can simply put message in chat. I will check that, right?
ओके सर.
But not like that. That you say, please sir, explain it again. Explain it again means I have to explain everything. You just mention the part, which part you want me to explain or revise.
ओके सर.
Right. You see, let me do few more points, then it will be clear to you, right? Because I'm finding left hand limit, right limit, and all at x equal to 1, at x equal to 2, at x equal to 3, at x equal to 4. So it will be clear to you later on as well. If not, then you could simple maybe write a message that do it again. So I will understand that you are asking the same question, right? So in this case, we would say f is continuous at x equal to 0. Keep that in mind, because I'm going to concluding that at the end, that it is continuous at this point, or that point. Right, let's move towards x equal to 1 now. At 0, it is continuous, it is done. We go to x equal to 1 now. Right, x equal to 1 is here. And I want to check its continuity. The first condition is, look at this carefully, whoever has asked the question, right? You will understand this. So in this case, f of 1 is what? F of 1, this will be, you see, 1 here, the graph is coming to this point, but there is a hole here. So it means at x equal to 1, the value is not 0, the value is defined here. If you draw a vertical line here, so this is the value of f at x equal to 0, which is obviously equal to 1. F of 1 is 1. From geometry it is clear. X is 1, y is also 1. Now 1 is interior point, so we would find limit, left hand limit and right hand limit both. So we first find left hand limit at x equal to 1. We write x goes to 1. There is no rule for the sequence that you find left hand limit first or right hand limit first. You can find either one first. To limit x goes to 1 from left side, 1 f of x bar means left hand limit. Left hand limit basically means you have to approach to that number from left side, from this side. We see, if I pick this value, which could be any value between 0 and 1, it should be going close to 1. Corresponding value of f y will be this point. On this graph, on the blue lines, we are having values of y. On the x-axis, we are having values of x. So when I say the value of x, I will mark on x-axis. And when I say value of y, I will mark on y-axis, or I will mark simply on the blue line. So next value, if I take this one, corresponding value of y will be this one. If I take this value here, it is here. So as I am getting close to 1 like this graph is going towards, or it is approaching towards which number? That is 1. Some students make a mistake. They say, okay, it is coming to this point, but is it get to 1, it jump here? No. We in case of limit, we are checking behavior of graph near that point. हम उस पॉइंट के करीब देख रहे होते हैं कि उस पॉइंट के करीब क्या हो रहा है, हम एग्जैक्टली उस पॉइंट पे नहीं देखते. तो जैसे जैसे मैं 1 के करीब जा रहा हूं, ये ग्राफ जो है, अच्छा एक चीज और, व्हेन आई स्पीक इन उर्दू प्लीज डोंट लुक इनटू द कमेंट्स देन, लुक इनटू द कैप्शंस देन. और मैं वही चीज दोबारा एक्सप्लेन कर रहा हूँ, वो ऑलरेडी मैं इंग्लिश में कह चुका हूँ, तो डोंट वरी अबाउट इट. तो जैसे हम 1 के करीब जा रहे हैं x की तरफ से, y का जो ग्राफ है वो जा रहा है किसकी तरफ, जा रहा है किसकी तरफ, ठीक है, वो 1 की तरफ ही है. दैट्स व्हाई वी से लेफ्ट हैंड लिमिट इन दिस केस विल बी व्हाट, दैट इज 1. So left hand limit is 1. Now we find right hand limit. x goes to 1 from right side, we put plus here. As I explained earlier, that at interior point you would check limit x goes to c, and limit x goes to c means you would find left hand limit and right hand limit both. Right? So if you approach to 1 from left side now, I will take this value. So corresponding value of y will be this one now, because you see graph for this part is here, it's not there. If I take this point, this one, if I take this point, it is this one, and so on. So you see, altogether, if I approach to 1 from left right now, like this one, what about the graph? This is the graph, and it is moving towards which point now? You see, this is 1. My fault, I'm sorry. The first part is not 1, it is 0. Right? Because you see, the graph is going towards x-axis, and value on x-axis is 0, it's not 1. I'm sorry for that. And in this case, you see, it is going towards 1. Are these two same? The answer is no. They are not same. One is 0, the other one is 1. It means limit x goes to 1, f of x does not exist. If doesn't exist, it means condition number 2 is not satisfied. Therefore, f is not continuous. Or you say it is discontinuous at x equal to 1. Okay, in second step, as I said, you would find left hand limit and right hand limit both. Okay. So in case of left hand limit, what would you do? You would approach to this one, to this point from left side, from here. As you see, as I approach to 1 from this side, the graph is going towards which point? Towards this point, which is 0. Value of x here is 1, while value of y is what? That is 0. So that's why I said left hand limit is what? That is 0. And for right hand limit, you would be approaching from this point direction, and for this direction, graph is not this one, graph is this one. So you see, graph is going towards which point? That is going towards this point, which is 1 now. It is not 0. So that's why I have written there right hand limit is equal to 1. Now left hand limit is 0, right hand limit is 1. Both are not same. Therefore, the whole limit doesn't exist. And if limit doesn't exist, condition number 2 is not satisfied. So we say the function is discontinuous at x equal to 1.
Excuse me, sir.
Yes.
Sir, check the text message inbox.
Yeah, I'm checking it. You don't need to tell it to me.
Okay, sir.
That was I explaining, Laiba. As I said, if you take left hand limit, you will take. Let me do another example for you. Let me check limit at x equal to 2, right? And Laiba, you should look into it carefully. And again, if you don't understand, then tell me. I will take another part then. So let's check continuity at x equal to 2 now. Okay, x equal to 2. This is the point 2, which is obviously the interior point. So the first part is what? First part, we will check f of 2. Now, what about the value of f of 2? You see, at x equal to 2, if you draw a vertical line here, this is not the value of y at x equal to 2 because there is a hole. The value of y at x equal to 2 is basically this point. So f of 2 is what? That is 2. f of 2 is 2. I hope that's clear. This is equal to 2. Now we find left hand limit and right hand limit. That is condition number 2. So left hand limit means you would take the values of x from left side. So x goes to 2 bar f of x means you would consider a value to the left of 2 here. What about the value of y? That will be taken here. Value of x is this one, value of y is this one. Value of x is this one, value of y is this one. So as I take the values of x approaching towards 2, what about the values of y approaching towards, it is 1. You see this point, it is 1. It is not approaching to this point. Exactly at this point, the value is this one. But limiting value is this one. As I explained earlier, finding limit is basically what? We are checking behavior of function. We are checking behavior of function in the neighborhood of that point. We don't check value exactly at that point, and that is done in part 1 basically. We see as I approach to 2 from left side, the graph is approaching towards what? This point. This point is basically what? The value of y is 1. So we would say limit is what? Limit in this case is 1. The left hand limit is 1. In similar way, if we find right hand limit, so approaching to this point from right side, you don't need to take the values, you just need to take the direction. If you approach to 2 from right side, the graph is going towards this point. And this point is again what? It is 1. So from here we can conclude that right hand limit is also equal to 1. X goes to 2 from right side, f of x, that is equal to 1 as well. Now in this case, left hand limit is same as right hand limit. Therefore we would say limit at x goes to 2 exists. And what is that limit? That limit is equal to 1. And then we move toward third condition. Okay. या होल का मतलब है कि यहां पर वैल्यू डिफाइंड नहीं है. Whole means value at that point is not defined, or it is defined differently. You see, this is the whole. So by pattern, following the pattern of the graph, value at x equal to 2 should be this point, but it is given no, at this point the value is not this one, it is something different, this one. The whole means the value is not there, the value is somewhere else, or it might not be defined. Okay, so in third condition, you see, you would say value obtained in 1 is 1, value obtained in 1 is 2, and value obtained in 2 is 1. Both are not same. You would say 1 value is not same as 2 value. Therefore condition number 3 is not satisfied, so function is again discontinuous. So f of x is discontinuous at this point. Yeah, it is turned on. I don't know why you are saying that.
सर वो अपना पॉइंटर ऑन करेंगे, जिस तरफ आप माउस लेके जाए ना, क्या मैं भी नजर आए उस तरफ, फिर अच्छी समझ आएगी।
नहीं, पॉइंटर तो ऑन है, आपको नजर नहीं आ रहा?
सर हमें नो सर, लाइन आपकी जो आप लाइन लगाते हैं वो नजर आती है, लेकिन पॉइंटर नहीं नजर आता ना जिस तरफ आप लेके जाते हैं।
नहीं, पॉइंटर तो ऑन है शायद, मे बी, आई डोंट नो क्यों नजर नहीं आ रहा आपको। असल में मैं वो राइटिंग कर रहा होता हूँ, आपको इसलिए नजर नहीं आता। अगर मैं इसको ऑन करूंगा तो फिर उधर मैं राइटिंग नहीं कर पाऊंगा ना।
यस सर,
अब
ठीक है।
अगर मैं इसको करूंगा ना इस तरह से, अब मैंने इसको ऑन कर दिया, अभी नजर आ रहा है आपको?
यस सर।
अभी अगर आपको नजर आ रहा है तो शायद मैं इसमें राइटिंग नहीं कर सकूंगा। सिलेक्शन होगी लेकिन राइटिंग में नहीं कर पाऊंगा फिर।
यस सर, ठीक है।
तो थोड़ा सा खैर आप भी उसको देखे ना कि मैं जहाँ पर राइटिंग कर रहा हूँ तो उधर वो होगा। मैं
यस
एरो
सर, ठीक
मैं एरो इसलिए मैं एरो ड्रा कर रहा होता हूँ ताकि आपको वो नजर आए।
है। यस सर, ठीक है, नो प्रॉब्लम।
Okay, now we check continuity at x equal to 3. Let me clear the board. Right. So if x is equal to 3, again, condition number 1, we check value of f. So f of 3 will be what? You see, I'm talking about now this point 3 here. Okay. Now value at 3 is, if I draw a vertical line here, value at 3 is what? That is 2. Value is 2 because at this point we are not having hole. Value at this point is the same as this one, so that's why we have 2. Now we check it again. 3 is an interior point. We would find both limits. We would find left hand limit and right hand limit. So I'm finding left hand limit again. Limit x goes to 3 from left side, f of x. See, if you approach to 3 from left side, like in this direction, the graph is going towards this point, which is, you see, that is again 2. It is approaching towards 2. That's 2. Right? So it means left hand limit at x equal to 3 is 2. Right hand limit at that point now we approach to 3 from right side, from this direction. You see the graph is going towards the same point, which is 2 here. That is 2 obviously. So right hand limit is also 2. So left hand limit and right hand limit both are same. Therefore limit exists, and this limit is what? This limit is x goes to 3f, that is equal to 2. Now, are these two values same? The answer is yes, they are same. So condition number 3 is also satisfied. Therefore, we say function is continuous at this point. Right? So f of x is continuous at x equal to 3. Now we check continuity at x equal to 4. I'm doing it very slowly to understand. You should understand it. Later on questions you will do it yourself. And मैं इसको इसलिए एक्सप्लेन भी कर रहा हूँ ताकि शायद मे भी आप लोग वो भूल चुके हों लिमिट्स वगैरह, तो इसलिए मैं दोबारा ये करवा रहा हूँ। अदरवाइज ये इतना मुश्किल चीज़ नहीं है। इट्स अ वेरी सिंपल स्ट्रेट फॉरवर्ड थिंग। अगर आप किसी और ईमेल से साइन इन होंगे तो आप बार बार मुझसे परमिशन मांगेंगे और फिर आप मुझे डिस्टर्ब करेंगे क्लास में। Okay, now we check continuity at x equal to 4. Keeping in mind x equal to 4 is the extreme, whatever, is the right end of the interval. So we check continuity at x equal to 4. Conditions are same. We first find f of 4. So f of 4, if you draw a vertical line by the pattern, it says the value should be 1. With the pattern, you see, it says the value should be 1, but there is a hole. It means value at x equal to 4 is not 1. So what is that? You would simply draw a vertical line, and this is the point where the value is given, and this value is maybe almost like 0.5. So if you write f of 4 is equal to 0.5, that will be okay. So f of 4 is 0.5. And now we are at the extreme left end of the interval, right end, sorry. So we would find only left hand limit. We don't need to find left and right both. I hope you remember that. I explained that at the beginning. So we find only left hand limit, and left hand limit will be what? If you approach to 4 from left end, the graph is approaching towards which number? That is 1. Keeping in mind, यहाँ पे अप्रोच नहीं कर रहा, मतलब इस डॉट पे अप्रोच नहीं कर रहा, यहाँ पे अप्रोच कर रहा है ये. जैसे आप कंफ्यूज ना हो, बात स्टूडेंट यहाँ पे कंफ्यूज हो जाते हैं, कहते हैं तो इधर आएगा, इधर नहीं आ रहा, ग्राफ यहाँ पे आ रहा है, उसका जो नाइबरिंग बिहेवियर है वो हमें देखना होता है, नॉट दिस बिहेवियर. So this limit is equal to 1, right? So limit exists. Condition 1 satisfied, condition 2 satisfied. What about condition 3? Is it satisfied? The answer is no. 1 is not equal to 2, because at 1 it is 0.5, while in 2 it is 1. So they are not same. Therefore, f is not continuous, or f is discontinuous at x equal to 4. Okay, I'm checking. ये ग्राफ में ऐसा गिवन है, मैंने अपनी तरफ से नहीं लिया हुआ, ये अब ग्राफ ही ऐसे दिया हुआ है. ओके, फॉर एग्जांपल देखें, अगर आप मोटरवे बना रहे हैं किसी टाउन के लिए, ठीक है, तो वो मोटरवे तो जा रही है, लेकिन जैसे आप उस टाउन तक पहुंचते हैं तो वो मोटरवे उससे पहले खत्म हो जाती है, वहां पे कोई और रोड बन जाता है. राइट, यू नो व्हाट आई मीन. So it is something like that, that exactly at that point we are having different situation of the function. At the neighboring part we are having different situations. We can have such type of functions in real life as well. It is something, if you know something about hydrodynamics or fluid dynamics, in that case what do? We have a sink and a source. The behavior of fluid at sink and source are completely different as compared to its behavior and the neighborhood. अगर आप ट्यूबवेल लगाते हैं और उससे पानी बाहर निकल रहा होता है, जहां पे पानी गिर रहा है वहां पे पानी का बहाव डिफरेंट होता है एज कंपेयर टू पानी का बहाव थोड़ा सा आगे जाएंगे. So that's natural. We may have some type of same type of functions naturally as well. So let's conclude this slide. Altogether, geometrically, if you know graph of a function, then a point where a function has a jump or a hole, the function will be discontinuous. A point where graph has a jump or a hole, the function will be discontinuous at that point. So in this case, we can see that f is continuous for all x belongs to starting from 0, continuous at 0, so I am taking closed interval, going up to 4, but discontinuous at 4, so open interval, except x is equal to which points? 1 and 2. You don't need to mention here except x equal to 1, 4, 1, 2, 4, because 4 is already excluded from here. But if you put closed interval here and here both, then you would say except x equal to 1, 2, and 4. But in this case, you don't need to write 4 again. You would simply say f is continuous for all x in this interval except x equal to 1, 2. So I hope you understood the basic concept. If graph is given, how would you check where is it continuous and where is it discontinuous? The general concept, if you have a jump, the function will be discontinuous. If you have hole, the function will be discontinuous. Some more, if we have jump at a point, that discontinuity will be because of condition number 2. Condition 2, which is non-existence of limit. Right? When we have a jump at a point in a graph, it means left hand limit and right hand limit will not be same, and limit doesn't exist at that point, and function will be discontinuous. And if we have a hole in a graph, like this case, this discontinuity will be because of condition number 3. But sometimes, if let's suppose if this was not given and this was only hole, and then this discontinuity is because of condition number 1. If we have hole, in that case, the discontinuity will be either because of condition number 1 or condition 3. And if we have jump, then discontinuity will be because of condition number 2. You must learn these things to decide about continuity at any point. I hope it is clear, everybody now. Anyone can ask a question now at this moment? Otherwise, I'm moving further then. Right. Now we check continuity of a function when mathematically, how do we do that? I hope you remember that the concepts are same. You must remember that how do you find left hand limit and right hand limit in case of unit step function and in case of piecewise defined function. All right, so we'll do that. That's the only thing. You will find left hand limit and right hand limit. So we want to check the continuity of greatest integer function at different points. Let me show first graph of it, and from graph you can conclude where will it be continuous and where is discontinuous. So if you see at the integers at 0, 1, 2, 3, 4, and so on, -1, -2, there are jumps. You see, we have a jump here, 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 and so on. It means at these points the function will be discontinuous. Right? At jumps, the function is discontinuous. It means that greatest integer function is discontinuous at integral values. And in the interval, you see, this part, there is no jump, there is no hole. So for non-integers, there is no jump, there is no hole, so the function is continuous there. Now, how do we do it mathematically? Graphically, I hope you understood it, and it's easy for you to check where the graph is continuous and where is not continuous. So how do we do it mathematically? So let me redefine greatest integer function again. I hope you remember that, but let me do that again. So f of x, which is greatest integer function, that is defined as, if you remember, it is 0 when x is between 0 and 1, it is 1 when x is between, you can check that in book as well, x is between 1 and 2, it is 2 when x is between 2 and 3, including 2 and excluding 3, it will be -1 if x is between -1 and 0, etc. It will be 3 if x is between 3 and 4, and so on. So this is a definition of what greatest integer function, right? I hope you remember that finding left hand limit. If not, I'm just giving you an idea. Limit x goes to a from left side, a bar f of x. I told you in case of unit step function, if you remove this bar, we change limit x goes to a with limit h goes to 0, and replacing x everywhere in that function by a minus h. That's what we do in case of left hand limit, replacing x with a minus h everywhere and applying later on limit h goes to 0. And for right hand limit, what do we do? It's plus there, this is same, and you may you replace x everywhere by a plus h. Okay, and there are some more results regarding greatest integer. I hope you remember that if a is integer, these results are true only for integers. So if a is integer means 0 plus minus 1 plus minus 2 or so on, and h is any small positive number, which is usually the case in limits. Okay, then a minus h greatest integer value is what? That will be a minus 1. कुछ याद आ रहा है कि नहीं थोड़ा थोड़ा? This will be a minus 1, while greatest integer for a plus h, this will be simply a. And if you remember, for least integer, a minus h was a, while a plus h was a plus 1. But you will do that yourself later on. So we'll be using this concept here to find left hand limit and right hand limit. Let me clear the board now, and I would find now left hand limit. So we consider two cases here. First we consider integer to check continuity at integer, and then we consider continuity at for non-integer. So how do we do it mathematically? I explained that graphically, which is very easy if you understood the concept I explained in last example. So I think it will be easy here as well. So we first consider integer. Let a belongs to z. We check continuity at integer. We would find, obviously, condition number 1 is very straightforward. You would find f of a, whatever a is, whatever not, it's f integer. So greatest integer value give you the same thing. Okay, you see, if a is 0, so f of 0 is 0. If a is minus 1, it is minus 1. If it is 1, it is 1. If it is 2, it is 2. So f of a is equal to a. That is defined. In second part, we will be finding left hand limit and right hand limit, because we are considering infinite interval, so every point will be the interior point. We consider x goes to a. From left side, x goes to a, f of x. By using left hand limit condition, as I said, you will replace limit by h goes to 0, and it will be replaced with a minus h. And as I explained earlier, limit h goes to 0, a minus h is equal to a minus 1. Now there is no h involved in it, so you would simply say this is equal to a minus 1. That's why if you see here, it is proved that limit x goes to a from left side, x greatest integer is equal to a minus 1. That's the proof to date. Similarly, if you find right hand limit, so I do that by changing simply bar with plus or minus with plus. This is plus, replace this with plus, but a plus h is what? You will remove this and it is only a now. And then applying limit h goes to 0, it will be a. Right? I can remove it, erase it as well. ये बहुत बड़ा हो जाएगा फिर. This is a, and this is equal to a. Now you see from here, that's the right hand limit given, which is a. Left hand limit was given a minus 1. So for any value of a, these two are not same. Therefore we say left hand limit is not equal to right hand limit, so limit doesn't exist. Therefore it is proved that f of x is equal to x greatest integer is discontinuous at x equal to a, where a is what? A is any integer. If somebody asks you, can you prove it that greatest integer is discontinuous at x equal to a, so you would say yes, I can, and that's the process to do it. That's good. Now we consider non-integer. If a doesn't belong to z, it's a very common thing. You know that if a is non-integer, but still a can be written between two integers. We can write that integer, non-integer a, between two consecutive integer, n is integer, right? For example, if you take 1.3, the 1.3 is non-integer, but 1.3 is between 1 and 2. 3.5 is non-integer, but 3.5 is between 3 and 4. So in that case, n will be what? N will be integer. So we say that if a is any non-integer, then a can be written as interior point of two consecutive integers. ऐसा नहीं है, अगर आप कहते 1.3 है तो 1.3 तो 0 और 3 के बीच में भी है. हम n और n minus 1 की बात कर रहे हैं. See, so n is integer, so if n is 4, n minus 1 will be 3. We talk about consecutive integers. So in that case, if you see here, that is proved here that limit, left hand limit, right hand limit, and exact value at that point is always equal to n minus 1. That's the lower limit of that interval which contains that non-integer. Why is it? I am explaining that by considering a very simple example. Maybe I take a value of a. So let's suppose a is equal to 1.4, maybe 1.5, maybe 1.3. It could be anything. In that case, n will be what? N will be 2. Because 1.3 is between 1 and 2. The greater integer is what? That is n. The smaller will be n minus 1. It's obvious. So n in this case is 2. Now, condition number 1, if we find f of a, that is f of 1.3, greatest integer 1.3. If you come here, 1.3 is between 1 and 2, and for any value between 1 and 2, this value is what? That is 1. And 1 can be written as 2 minus 1, or we may say that it is n minus 1, because n in this case is what? That is 2. So that's why we say that a greatest value is what? If a is non-integer, is n minus 1. Okay. Similarly, if you go for condition number 2, in condition 2, obviously we'll be finding left hand limit and right hand limit. Limit x goes to 1.3 bar greatest integer x, that will be limit h goes to 0, and we would replace x by what? 1.3 minus h. Now you see, what is it? Limit h goes to 0, 1.3 minus h. You see, 1.3 is in the interval 1 to 2. If we subtract a very small positive number from 1.3, will it not be in the same interval? 1.3 जो है 1 और 2 के बीच में है, बहुत छोटा नंबर 0.01 आप सब्ट्रैक्ट करेंगे तो वो भी इसी इंटरवल में रहेगा. It means 1.3 minus h is still equal to what? That is 1. And then if you apply a limit, there is no h involved in it, so it will be 1, which can be written as, again, as I said, that is 2 minus 1, which is equal to n minus 1, because n is taken as 2. But that's why left hand limit is also n minus 1. If you find right hand limit, so we simply replace plus here. This will be plus okay. You see, as I said, अगर कोई नंबर 1 और 2 के बीच में है, 1.3 1 और 2 के बीच में है, उसमें से 1.3 से आप बहुत स्मॉल नंबर सब्ट्रैक्ट करें. स्मॉल नंबर 0.01 0.001 समथिंग लाइक दैट. स्मॉल नंबर 0.7 नहीं सब्ट्रैक्ट करोगे, 1 नहीं सब्ट्रैक्ट करोगे, 0.001 or 0.01, something very small. So 1.3 minus that quantity, let's suppose we subtract it, 1.3 जो कि 1 और 2 के बीच में है, इससे आप 0.01 सब्ट्रैक्ट करें, let's suppose, so that becomes 1.28 something. तो 1.3 अगर 1 और 2 के बीच में है, तो क्या 1.28 भी 1 और 2 के बीच में नहीं है? तो 1.3 minus h is still in the same interval 1 2. And what is the value of greatest integer in the interval 1 2? That is 1. That's why I replaced 1.3 minus h greatest integer by 1. And then applying limit h goes to 0 to get this one. The same concept for 1.3 plus h as well. 1.3 plus h is also 1, because if you add a very small number to 1.3, it remains the same. If you add 0.001, it becomes 1.301 or it becomes 1.31. So 1.3 is in the interval 1 2. It will 1.31 will also be in the interval 1 2. In that case, it is also 1, which is 1 to applying limit. There is no h involved in it, so we'll get 1 back. That is 2 minus 1 and n minus 1. So right hand limit is also equal to, this is also equal to what? N minus 1. So left hand limit is n minus 1, right hand limit is n minus 1. Value at that point is also n minus 1. So all three conditions are satisfied. Therefore, the function is continuous at non-integer values. So that's the proof for it. ये बाकी लेक्चर्स में, बाकी सब्जेक्ट्स में भी ऐसी एक्सप्लेनेशन आप लोग मांग रहे हैं इतना डिटेल से? नहीं मांग रहे ना, मुझे पता है
सर मांग रहे हैं, लेकिन वो तो
सर
थ्योरी होती है तो हमें समझ आती है सर। ये तो मैथमेटिकल चीजें है सारी सर, तो इसमें तो एक्सप्लेनेशन जरूरी है।
क्या बात है, एक्सप्लेनेशन जरूरी है, बाकी चीज़ों में एक्सप्लेनेशन जरूरी नहीं होती, मैथमेटिक्स में
सर
जरूरी
होती है सर होती है, लेकिन सर वो हम खुद भी पढ़ सकते हैं सर, और थ्योरी होती है तो हमें खुद भी समझ आती है सर। टीचर थोड़ा सा भी एक्सप्लेन करे सर तो हमें समझ आती है।
इंजीनियर्स को मैथमेटिक्स की समझ आनी चाहिए।
एक्सक्यूज मी सर, सर इससे पहले आपने जो ग्राफ दिखाया है ना, उसमें तो होल्स थे,
या
तो वो तो वहाँ पर डिसकंटिन्यूअस है ना, तो आपने कहा कि वहाँ पर वो कंटिन्यूअस होगा। ये सर इसमें
मैंने कहा यहाँ पर जहाँ पे 1 है, 0 है, 1 है, 2 है, यहाँ पे जंप्स हैं। यू सी, ये जंप है, इधर भी जंप है, इधर भी जंप है, इधर भी जंप है। तो इन जंप्स पे ये डिसकंटिन्यूअस। अपना माइक बंद कर लिया करें फिर, ठीक है? आपने पंखा भी लगाया हुआ है और आप पता नहीं कहीं किसी ज़मीन में बैठे हो, पटो के नाचते हो, खरबूजेम रुबुजेम फ्रे हो, लासम को हो रहेगा, ठीक है? तो यहाँ पे जंप्स हैं, तो जहाँ पे जंप है वहां पे ये डिसकंटिन्यूस है। यही हमने प्रूफ किया। दैट्स व्हाट वी प्रूव्ड हियर, दैट greatest integer function is discontinuous at integer values. You see, at 4 integer value discontinuous. Here 3 is integer, we have a jump discontinuous. 2 is integer, we have a jump discontinuous. 1 is integer discontinuous, we are having jump. 0 is, and then -1 is integer, so they are discontinuous here. While in between these integers, you see here, from 0 to 1, I said there is no jump, there is no hole here. Between 0 and 1, this part, between 0, 1 and 2, this part, जिसको हमने n और n-1 की बात की, वो यहाँ पे हम बात कर रहे हैं। यहाँ पे इनके बीच में, do you see any jump or hole? No, obviously not. So it is continuous at these points and discontinuous at the integer values. मैंने ये बात की थी, मैंने ये नहीं कहा था कि वहां पे तो ऑब्वियसली जंप, जहां पे जंप है वहां पे वो डिसकंटिन्यूस होगा।
और सर इसमें ये जो होल्स है, मतलब 2 पे होल्स है, 3 पे होल्स है, तो लेफ्ट और वो राइट लिमिट जब हम लेंगे तो उसमें फिर ये 1 कंडीशन और 3rd कंडीशन पे, तो ये फिर वो होगा
डिसकंटिन्यूस हो गया ना। ऑब्वियसली वो तो जंप, देखिए ना, अगर हम 1 पे लेफ्ट हैंड लिमिट ले रहे हैं ना, 1 पे अगर हम लेफ्ट हैंड लिमिट ले रहे हैं, यू सी हियर, तो लेफ्ट हैंड लिमिट अप्रोचिंग टू 1 इज गिविंग यू 0। 1 पे अगर हम राइट हैंड लिमिट ले रहे हैं तो वो आपको 1 दे रहा है। यू सी द ग्राफ इज गोइंग देयर। तो तो लेफ्ट हैंड लिमिट इज 0, राइट हैंड लिमिट इज 1. दैट्स व्हाट वी सेड देयर कि लेफ्ट हैंड लिमिट और राइट लिमिट दोनों बराबर नहीं है. पिछले उसमें हमने किया ना, लेफ्ट हैंड लिमिट वाज a minus 1 while right hand limit is a. दोनों डिफरेंट आ रहे हैं. You see here, both are different exactly at the integer. But if it in non-integer की हम बात करें, let's suppose if we talk about this point here between 2 and 3, so in this case if you find left hand limit here, you are approaching to this point from left, and if you approach to this point from right, the graph is going toward this point from right. So in both cases this is approaching to which point? To 2. So at this point left hand limit and right hand limit both are 1. Sorry, both are 2, right? At x equal to 2.5 if you consider. तो अगर इंटरमीडिएट पॉइंट है तो वहां पे तो ठीक है, लेफ्ट और राइट दोनों बराबर होंगे. लेकिन अगर आप बात कर रहे हैं ध्यान में रहे, जब मैं बात करूं अप्रोचिंग टू दैट पॉइंट फ्रॉम लेफ्ट और राइट, इसका मतलब ये नहीं है कि मैं यहां से अप्रोच करना शुरू करूं, इधर से ऐसे मैं अप्रोच करूं. नहीं, ऐसा नहीं है. उस नंबर के करीब आपने लेना होता है. अगर आप यहां से करेंगे तो फिर तो ऑब्वियस है, यहां पे आएंगे तो इधर के लिए वैल्यू यहाँ पे है, यहाँ पे है, यहाँ पे है. बहरहाल हमें इससे कोई काम नहीं है, हमने क्लोज वैल्यू यहाँ पे लेनी है. ये तो इंटरमीडिएट के लिए क्या है, ये वो क्या कहते हैं इसको, लेफ्ट हैंड लिमिट और राइट लिमिट दोनों बराबर हैं, जबकि जो इंटीजर वैल्यूज हैं उसके लिए दोनों बराबर नहीं है.
ओके सर, सही हो गया.
क्लियर हो गया? ओके, गुड.
यस सर, यस सर. थैंक यू सर.
So let's move further. I'm giving you 2 minutes and you check that these functions are continuous at which points and discontinuous at which points. You can write in comments only. Everybody should write in comment. Part A, B, C, D, and so on. Right? Write in comments only. ओके, स्टॉप कमेंट्स. इस एक्सरसाइज का बेसिकली मेरा मकसद ये था कि लेटर ऑन विल बी हैविंग मिड टर्म एग्जाम एंड दैट विल बी ऑनलाइन एग्जाम. So if I ask any one question this is not a way to write comments, because you are saying this one is this one, and you are giving me answer one by one, and in each comment you are answering one question. You should answer all the question in one comment. There are 27 students present in the class, and I am having more than 40 comments, so this is not a good way. Okay. Now I'm explaining it, and you check whether you have done correctly or not. Right, the first graph, part A, it is continuous everywhere, because you see there is no hole, there is no jump in it, so this is continuous everywhere. Okay, while in the second graph, you see, again, there is no jump for x less than 0, no hole for less than 0, there is no jump, no hole for x greater than 0, but there is a hole at x is equal to 0, hole here, no hole there, no hole here. So the function is continuous everywhere except x equal to 0. And the reason is what? The reason is f of 0 is not defined in this case. F of 0 is not defined, doesn't exist. You see that exactly at x equal to 0, there is no bold point. You see, अगर हम यहाँ से कोई लाइन ड्रॉ करते हैं ना, इधर से वर्टिकल लाइन ड्रॉ करते हैं, तो किसी भी जगह पे वो वैल्यू नहीं है जिसकी हमें जरूरत होगी. So in this case, f of 0 is not defined. While in part C, in this case, it's almost the same graph. The only difference is what? F of 0 is also defined, but they are not same. F of 0 is given here. It is 2. By looking at the pattern of graph, it should be 1, but it is given that it is 2. It's not 0 now. So again, it is discontinuous at x equal to 0 because there is a hole in the graph. These two types of discontinuity, part B and part C, these two types of discontinuity are known as removable discontinuity. We call it removable discontinuity. What? HO what? Do you see a hole in the part C? There is a hole, as I explained earlier. If a graph has a hole at a point, it will be discontinuous. It's a very simple thing. So in part C, if you see, there is a hole right here. The value is defined, limit exists. You see, both limits are going toward the same number 1, but value and limit are not same. Condition number 3 is not satisfied. So this type of discontinuity are known as removable discontinuity. So what is a removable discontinuity? That is, if a function is discontinuous, function is discontinuous at a point, but limit at that point exists. अगर एक फंक्शन किसी पॉइंट पे कंटिन्यूस है लेकिन लिमिट वहां पे एग्जिस्ट नहीं हो रहा, लिमिट x गोज टू c, सॉरी एग्जिस्ट हो रहा है, लिमिट x गोज टू c f of x exists, that point of discontinuity is called a removable discontinuity. In other words, we say discontinuity because of condition 1 or 3. If condition 2 is satisfied and either 1 or 3 are not satisfied, a function will also will be discontinuous, and such type of discontinuity is known as removable discontinuity. So example given in part B, or graph given in part B and C, they are having a removable discontinuity, where the first part B is discontinuous because of condition 1, and C is discontinuous because of condition 3. In both cases, second condition is satisfied. While if you come back to part D, it has a jump at x equal to 0. It is continuous everywhere except 0, and there is a jump, right? So this type of discontinuity is known as jump discontinuity. I'm writing shortly JD. We call it jump discontinuity. We may call it permanent discontinuity. We may call it non-removable discontinuity. A discontinuity where limit doesn't exist, or discontinuity because of condition number 2, that is known as jump discontinuity, permanent discontinuity, or okay, wait for a while, somebody is calling again and again, so let me. Sorry, I had someone was calling again and again and again. I thought might be emergency something. Okay, ji. So this type of discontinuities are known as jump or permanent or non-removable discontinuity. If you see part E, in part E, f of 0 is what? F of 0 is infinity in this part. Function is given, that is 1 over x square. Now function is known, graph is also known. So f of x is 1 over x square, and if you find f of 0, that will be infinity. So f of 0 is undefined, therefore the function is discontinuous. Directly you can say that. But which type of discontinuity it is? In this case, if we find left limit, this is infinity. If you find right hand limit, it is also infinity. And how did I observe it? You see, as I get close to 0, the graph is going towards infinity. You see that it's going towards infinity. Similarly, if you go to 0 from right side, the graph is still going towards infinity. Sometimes it is not the case. So it means limit as a whole is what? That is infinity. So if for a function, you see, left hand limit, right hand limit, both are infinity. So we say left hand limit and right hand limit are same. Therefore, limit exists, but limit is undefined. It is infinity. Right? So if for a function, f of 0 is infinity, limit is infinity, but limit exists. So we say this type of discontinuity is infinite discontinuity. This is not a relevant question. I am recording the lecture. You should ask this question at the beginning. Otherwise, अगर इतना lecture गुजर गया तो recording का कोई फायदा नहीं है फिर तो. अभी आप कह रहे हो कौन record कर रहा है? Okay. So this type of discontinuity is known as infinite discontinuity. ज़रूरी नहीं है कि अगर लिमिट इन्फिनिटी हो तो वो हमेशा के लिए क्या होगा, एग्जिस्ट भी करेगा. If you consider f of x is equal to 1 over x, in this case f of x is what? That is f of 0, sorry, f of 0 is infinity, but f of 0 is infinity. But if you draw the graph of 1 over x, you might have seen it somewhere. We had a discussion about it in the class. It has a graph like that. So you see, if in this case we find left hand limit, the graph is moving towards minus infinity, while if you approach to 0 from right side, it is going towards plus infinity. So in this case, the limit does not exist. It is not infinity. Limit x goes to 0, 1 over x is not infinity, it is plus infinity. If you approach to 0 from right side, it is minus infinity if you approach to 0 from right side. Plus infinity, minus infinity. So that limit doesn't exist, right?
Excuse me.
Yeah.
सर ये जो आपने रिमूवेबल जो डिसकंटिन्यूटी के बारे में बात की है कि वो या फर्स्ट कंडीशन या थर्ड कंडीशन की वजह से होगी सर.
Yeah.
तो थर्ड कंडीशन तो तभी आएगा ना सर जब सेकंड कंडीशन हम अप्लाई करेंगे उसके ऊपर, तो फिर तो ये नॉन रिमूवेबल भी हो जाएगी सर.
तो वही तो मैंने कहा ना, देखिए मैंने नॉन रिमूवेबल के लिए मैंने यही कहा कि अगर कंडीशन नंबर 2 सेटिस्फाइड हो,
यस सर.
I said a function has a discontinuity at a point x equal to c, but limit x goes to c, f of x exists.
ओके सर.
ये मैंने बोला था ना, मैंने लिखवाया यही था आपको. कंडीशन नंबर 2 मतलब वो सेटिस्फाई होगा, इसलिए मैंने 1 और 3 की बात की है. कंडीशन मैंने कहा discontinuity at a point c, but limit at that point exists, so we call it removable discontinuity.
ओके सर.
Right. This type of discontinuity is known as infinite discontinuity, as I said. In part F, you see, if you get close to 0 from either side, the function is oscillating, right? And in this case, we say limit x goes to 0, and this particular function sine 1 over x doesn't exist from either side, left side और राइट साइड. हमें कोई नंबर नजर नहीं आ रहा जहां पे ये ग्राफ अप्रोच करेगा. जैसे ही आप 0 के करीब जाएंगे, द फंक्शन विल बी ऑसिलेटिंग बिटवीन -1 and 1. So we say this limit doesn't exist. So left hand limit doesn't exist, right hand limit doesn't exist, as a whole limit doesn't exist. This type of discontinuity is known as, you see here in this case the function is oscillating near 0. Here you see something like that. Okay. So we say left hand limit doesn't exist, right doesn't exist. This type of discontinuity is known as oscillating discontinuity, something like that. वो लिखा हुआ है अगले स्टार्ट में, क्या नेम है क्या नहीं है, right? These are some special type of discontinuities. हमारा जो मेन इंटरेस्ट रहेगा वो removable में आएगा. We'll be considering removable discontinuity a bit more. So next slide is about all the same thing. You see, in part A, function is continuous everywhere except, more particularly continuous at x equal to 0 as well. In part B, it's discontinuous at x equal to 0 as f of 0 is not defined. That's discussed already, so you would look at it yourself. Right. Next is a continuous extension at a point. And next class, if you are entering the class from any other email or any other way, I will not admit you. I will deny entry. You must enter the class through your official email. Yeah, so I said it's infinity, so the function is discontinuous. Ahmad Hussain, right? The function is discontinuous because the first condition is not satisfied, so it's okay. But this type of discontinuity is known as infinite discontinuity. So we are basically defining a type of discontinuity at this moment. We don't talk about continuity at that, but it's discontinuity, it's obvious. Okay, let me take attendance again. Right. Now we talk about continuous extension of a function. What do we mean by continuous extension? Continuous extension means if you redefine a function in such a way that it becomes continuous at a specific point. हम फंक्शन को एक ऐसे अंदाज में रीडिफाइन करें कि जहां पे वो डिसकंटिन्यूस था जिस पॉइंट पे, वहां पर वो क्या हो जाए, वहां पे वो कंटिन्यूस हो जाए, तो वी से द फंक्शन इज बीइंग एक्सटेंडेड एज कंटिन्यूस फंक्शन, और उसको फिर हम कंटिन्यूस एक्सटेंशन कहते हैं। उसके लिए पहली कंडीशन जरूरी है, द फर्स्ट कंडीशन फॉर फाइंडिंग कंटिन्यूस एक्सटेंशन, दैट फंक्शन मस्ट हैव removable discontinuity. If a function has non-removable discontinuity, we cannot find its continuous extension. It must have a removable discontinuity. I'm writing shortly RD, which means a removable discontinuity. Okay. तो यू वुड डिफाइन, ऑब्वियसली अगर किसी पॉइंट पे रिमूवेबल डिसकंटिन्यूटी है तो इसका मतलब यह है कि या तो एफ ऑफ सी डिफाइंड नहीं होगा, लिमिट तो एग्जिस्ट करेगा, या फिर क्या होगा, आखिरी कंडीशन लिमिट और वो दोनों वैल्यू सेम नहीं होंगे। तो इफ यू मेक दिस वन, यू सी लिमिट इफ इट इज हैज अ रिमूवेबल डिसकंटिन्यूटी, तो लिमिट एक्स गोज टू सी और एफ ऑफ सी, इफ दे आर नॉट इक्वल, so you will make them equal simply. That's what it call it to make it continuous at that point. How do we do it? Let's do an example. आपको क्लियर हो जाएगा फिर। Very simple thing. This is x is not equal to 2. So it says show that this function has a continuous extension at x equal to 2. And find that extension. When you are asked show that a function has a continuous extension, it means that function must have a removable discontinuity. We see the function is defined for x is not equal to 2, but it is not defined for f for x is equal to 2. If somebody asks you what is f of 2, you would say f of 2 doesn't exist. Yeah, it is not defined. F of 2 in this case does not exist. Okay, so it means if f of 2 doesn't exist, while what about the limit? Limit of this function can be found easily. You see, factorize karoge, factorize this function, that is x minus 2 x plus 3 by x minus 2 x plus 2. You simple cancel the common factor there, you get x plus 3 by x plus 2, and then applying limit x goes to 2, we get 5 by 4. So limit at this point exists and f of 2 doesn't exist. So because of condition 1, the function is discontinuous, and that discontinuity is what? It is a removable discontinuity. As limit exists while value at that point doesn't exist. So how do we find its continuous extension? I would redefine the function in following way. You would write f of x is equal to, that's what you would do all the time for finding continuous extension of a function. So f of x is equal to You would write the function exactly as it is. You would say x square plus x minus 6 divided by x square minus 4 when x is not equal to 2, and you would define it from your side for x equal to 2. What would be the value at x equal to 2? That would be simply the limit you have found. You would give that value to x equal to 2. ये एग्जाम्पल का मतलब क्या है? मीन्स ये हमसे क्या? I'm explaining that in this case, you see, basically we want to find continuous extension. And what do you mean by continuous extension? I'm explaining that by a very simple practical example. But that's the way to do it. The function is defined for everything except 2. So the function will be discontinuous at that point. We want to redefine the function in such a way it is continuous everywhere. It must be continuous at x equal to 2 as well. So we give value to that function at x equal to 2, and what would that value be? That should be the limit. देखें, एक सिंपल एग्जांपल है. अगर हम कोई बिल्डिंग कंस्ट्रक्ट कर रहे हैं, कोई वॉल बना रहे हैं, और उस वॉल के अंदर कहीं पे आपसे सुराख रह गया, जो कि यूजुअली रह जाता है, होल रह जाता है उसमें, ठीक है. तो हम क्या करते हैं, उसको बड़ी आसानी से आप उस होल को बंद कर सकते हैं. कहता है कि खख्ता किए दे या सब के बलसो के या के बाजरी आशा है, राइट. बट इफ देयर इज अ परमानेंट डिस्कंटिन्यूटी, आप दो वो मिला रहे हैं, एक वॉल एक तरफ से आ रही है, दूसरा दूसरी तरफ से आ रही है, और वो कहीं और जा रहा है, दूसरा कहीं और जा रहा है, तो क्या उसको आप सिंपली मतलब विदाउट रिकंस्ट्रक्टिंग द होल स्ट्रक्चर कैन यू फिक्स दैट वॉल? द आंसर इज नॉट. तो आपने वो फिक्सिंग कैसे करनी है? मैथमेटिकली हम बात कर रहे हैं, नॉट प्रैक्टिकल. तो आप उसमें बके दे बके, बट मैथमेटिकली इट मीन्स दैट यू कैन फिक्स दैट होल बाय redefining function as giving a value to function at that point as the limit. तो ये इसका बेसिकली मकसद है. अगर आप किसी पॉइंट पे, जैसे मैंने कहा सिंक और सोर्स की मैंने बात की है, तो सिंक और सोर्स का अगर आप स्टडी करना चाहते हैं, आप पूरे उसको कंटिन्यू बनाना चाहते हैं थ्रू आउट, तो हम क्या कर लेते हैं, उसको भी वही एटीट्यूड, वही वैल्यू दे देते हैं जो उसका लिमिट होता है. उसके नेबरहुड में जो कुछ हो रहा है उसको भी वही हम कंसिडर कर लेते हैं, ठीक है ना. अगर आप किसी घर के बारे में इंफॉर्मेशन हासिल करना चाहते हैं, ठीक है, तो वही लिमिटिंग कंसेप्ट है. आप डायरेक्ट जाके उनसे नहीं पूछते, आप उसके पड़ोस में पूछते हो, ठीक है. पड़ोसी जो कुछ कहते हैं, फिर आप कहते हैं भाई ठीक है, जो पड़ोसी कह रहे हैं वही हम उसके बारे में बात कर रहे थे. तो आपने क्या कर दिया, उस पॉइंट पे जो वैल्यू है आपने वही वैल्यू दी जो उसके पड़ोसी कह रहे हैं. दैट इज समथिंग कॉल्ड कंटिन्यूअस एक्सटेंशन. हाँ, अगर आपको एक तरफ के लोग जो हैं वो कुछ कह रहे हैं, वो कह रहे हैं बड़े अच्छे लोग हैं और ये बड़े बड़े फलाना है, जबकि उसके दूसरे साइड पे जो लोग हैं वो कह रहे हैं नहीं यार ये तो बड़े खराब लोग हैं और ये भी करते हैं, वो ये भी करते हैं, वो भी करते हैं, देन यू विल नॉट बी एबल टू डिसाइड अबाउट द पीपल प्रेजेंट इन दैट हाउस और व्हाटएवर. तो उस केस में फिर आप ये नहीं कर सकते, कंक्लूजन नहीं भाई कि अच्छे लोग हैं या बुरे लोग हैं, आप कंफ्यूज होंगे. तो आपको कुछ और करना पड़ता है, पढ़ना होता है फिर. तो ये इसका बेसिकली एडवांटेज होता है जो हम अगर इसको सब वो कर रहे हैं. Any question up to here? You can speak even though. अगर आपको क्वेश्चन लिखने में टाइम लग रहा है, because I'm waiting for your question. संप मेला के नाश्ते का सिंगा चल रहे.
Excuse me, sir.
Yeah, I'm waiting for the question.
सर लिमिट के डिफिनीशन में सर अगर हम एक फंक्शन देखते हैं सर जो कि एक्स एक्सिस के बिल्कुल पैरेलल हो, सर सिमिलर फंक्शन, सर तो उसमें अगर हम लेफ्ट या राइट पे मूव कर रहे हैं सर तो वैल्यू तो एग्जैक्टली सेम है नेबरहुड की, मतलब उस वैल्यू को अप्रोच तो नहीं कर रही, बिल्कुल सेम वैल्यू आ रही है थ्रू ऑल
ओके,
द रियल लाइन।
इट्स ओके।
सर ये सर तो
अप्रोच तो कर रही है ना, अप्रोच तो कर, लेकिन वो हॉरिजॉन्टल लाइन से अप्रोच कर रहे हैं, दैट्स ओके। अब
सर
चाहे एग्जैक्टली उसी पॉइंट पे अप्रोच कर रही है या कुछ का भी कर रहे है, इट्स नॉट एन इशू।
यस सर, थैंक यू सर।
इससे फर्क नहीं पड़ता जी। एनीवन एल्स? आई साइंड आउट एंड अभी दोबारा साइन इन हुआ हूँ, तो अभी अगर मैं रिकॉर्डिंग करूंगा तो शायद वो रिकॉर्डिंग मेरे पास उसके राइट्स नहीं होंगे। तो आप ऐसा करें कि आप सारे साइन आउट हो जाएं और फिर साइन इन हो जाएं, ठीक है? तो फिर मैं
सर
जी
एक्सक्यूज मी सर, सर मैं रिकॉर्डिंग कर रहा हूँ सर पहले से, मैं आपको फिल्म मेल कर दूंगा सर।
नहीं, रिकॉर्डिंग आप नहीं कर, रिकॉर्डिंग मैं कर रहा हूँ ना।
सर
रिकॉर्डिंग तो
तो
ऑलरेडी
मैं कर सकता हूँ
आपने
सर।
आपने स्टार्ट किया, अभी स्टार्ट कर दिया आपने।
सर स्टार्ट से वो रिकॉर्डिंग मेरे पास भी है सर, मैं सेव कर सकता हूँ। आपने स्टार्ट किया सर, जैसे भी मैं साइन इन हुआ रिकॉर्डिंग स्टार्ट हुई थी सर पहले से, अभी मैं
तो
सेव
वो
कर
तो मैंने
सकता हूँ
स्टार्ट की थी ना, वो मैंने स्टार्ट की थी ना।
सर, लेकिन मैं सेव कर सकता हूँ पहले से जो रिकॉर्डिंग रिकॉर्ड हुई है सर सारी क्लास।
उसमें सेव करने का मसला नहीं होता, उसमें मसला होता है कि फिर आप शेयर नहीं कर सकते ना, इशू ये होता है। इसमें फिर
ओके
राइट्स
सर,
जो है वो किसी और के पास चले जाते हैं।
ओके
एनीवे
सर।
लेट्स सी, अभी रिकॉर्डिंग तो चल रही है अभी, लेट्स सी व्हाट्स गोइंग ऑन। अदरवाइज फिर आप वो मुझे से वो कर देंगे फिर, राइट? तो लेट मी शेयर द okay, let's move toward the next one. That's exercise 2.5. You can see that in book. You have to tell where the function is continuous and where is discontinuous. So मेरे ख्याल में it's clear to everybody now. क्यों डिसकंटिन्यूस है, रीजन भी आपको पता होगा, जहाँ पे होल है वहाँ पे क्या होगा, जहाँ पे जंप है वहाँ पे क्या होगा। तो यू कैन डू क्वेश्चन नंबर 1 to 4। क्वेश्चन नंबर 5 से 10 तक आप अगेन इस ग्राफ को यूज करेंगे या इस फंक्शन को यूज करेंगे, ठीक है? अभी मैंने एक्सप्लेन नहीं किया हुआ है कि अगर हमारे पास पीस वाइज डिफाइंड फंक्शन है तो उस केस में फिर हम लेफ्ट हैंड लिमिट और राइट लिमिट कैसे फाइंड करते हैं। आई एम डूइंग दैट इन नेक्स्ट क्वेश्चन, तो यू विल अंडरस्टैंड दैट, right? So at this question you will do, you should answer all the question by using graph given here. In the question they are saying, question 5, does f of -1 exist? You would see if you have the value is not defined at f of -1, you would say it doesn't exist. Then you would find the limit. You do all these things yourself. You got any problem, you can ask me then later on in next lecture possibly, or you may pose any question on in the classroom as well. बिकॉज जो मैंने एक्सप्लेन किया वो सारी चीज़ें इसमें यहाँ पे है, आपने सिर्फ उस पर प्रैक्टिस करना है कि मैंने जो एक्सप्लेन किया वो आपको समझ आया कि नहीं आया, राइट? ये अभी जो लास्ट मैंने एक्सप्लेन कर दिया कि हाउ टू फाइंड कंटिन्यूस एक्सटेंशन फॉर अ फंक्शन, ये उससे रिलेटेड क्वेश्चंस हैं। यू कैन प्रैक्टिस ओनली वन क्वेश्चन, यू शुड डू वन क्वेश्चन जस्ट टू अंडरस्टैंड द बेसिक कंसेप्ट. What would you do? You would find limit of g of x at x equal to 3, okay? And you see this limit exists, and that will be obviously x minus 3x plus 3 to give you x plus 3. और फिर लिमिट अप्लाई करेंगे, x goes to 3, that will give you limit as 6, okay? So you will assign 6 to g of 3 to make it continuous. The same thing for h of 2, the same thing for f of 1, and so on. I hope you can do that. Right, I'm explaining this one now here. You see, it say for what value of a this function is continuous at every x. Okay, you see, it's a piecewise defined function, and I will be explaining that how to check continuity. You see, before I move towards continuity at every point, let me tell you one thing. Polynomials are continuous. Polynomials are continuous for all x in the domain. ये जनरल स्टेटमेंट है. पॉलिनॉमियल्स जो होते हैं वो हर जगह पे कंटिन्यूस होते हैं उसके डोमेन में. इफ यू सी हियर in this case for x less than 3 and x greater than 3, not equal to 3, x less than 3 and x greater than 3, we are having polynomials. You see, x square minus 1 is polynomial, 2ax is a polynomial. So these functions are continuous everywhere. So we would check only continuity at x equal to 3, or we would make this function continuous at x equal to 3, right? So for that, what would we do? We would find left hand limit. How do you find left hand limit in case of piecewise defined functions? Let me do that generally. If you find limit x goes to a f of x, it's a general concept. In case of piecewise defined function, PWD, in case of piecewise defined function, what do we do? If you remove this bar, if you say limit x goes to a f of x, you will immediately impose a condition on it, that is x is less than a. Okay, while for plus symbol, for right hand limit, you would impose condition x greater than a. ये मैंने एक्सप्लेन किया था क्लास में, अगर आपको याद हो, सिर्फ रिवाइज करवा रहा हूँ. अगर आप क्या करें, लेफ्ट हैंड लिमिट फाइंड करें, तो जैसे आप इसको हटाएंगे, यहाँ पे क्या हो जाएगा, x लेस देन a कंडीशन आएगा. अगर प्लस यहाँ पे और उसको आप हटा रहे हैं तो x ग्रेटर देन a का कंडीशन आ जाएगा. We would apply this method for finding left hand limit and right hand limit at x equal to 3 now. So limit x goes to 3, first we find left hand limit f of x which will be, as I said, x goes to 3, f of x, and you would impose condition x is less than 3. Now for x less than 3, function is defined as, you take limit x goes to 3. For x less than 3, the function is defined here, you see, that is x square minus 1 putting this limit to get 9 minus 1 is 8. The left hand limit is 8, while right hand limit f of x, that is limit x goes to 3, यहाँ पे प्लस लगाएंगे, x goes to 3 f of x with condition x is greater than 3. And you know, for x greater than 3, the function is defined as 2ax. You put this value to get 6a. Now the function will be continuous if these two are same. We will make these two quantities equal. That is 6a is equal to 8, because we want this function to be continuous everywhere. So we want this function to be continuous at x equal to 3 as well. Therefore 6a will be 8, implies a is equal to 8 by 6, which is 4 by 3. So if we take a 4 by 3, the function will be continuous. Otherwise the function will be discontinuous at x equal to 3. Clear? आसान है, कोई मुश्किल चीज इसमें नहीं है. Right. And the next slide, the same is already done. So you see we check continuity at x equal to 3. Left hand limit is 8, right hand limit is 6a, as I've done there, and then 6a is equal to 8 implies a is equal to 4 by 3. These are some more questions you can do yourself. You will check continuity at x equal to -2 here, left hand limit at -2, right hand limit at -2, and equate them to get the value of b. Same thing here. Check left hand limit, right hand limit at x equal to 2, and then equate them to get the value of a. Similar situation here. Find left hand limit and right hand limit at x equal to 0. In 45, we are having a and b both, and there are 3 splittings. Now you may have a question in mind कि हम सिर्फ ये 2 पे या -2 पे या 0 पे क्यों चेक कर रहे हैं. जिस पॉइंट पे इंटरवल स्प्लिट होगा उस पॉइंट पे आपको चेक करनी होगी कंटिन्यूटी की, वहां पे फंक्शन कंटिन्यूस है या नहीं है. ठीक है, यू हैव टू मेक इट कंटिन्यूस टू फाइंड द वैल्यू ऑफ ए एंड बी. अगर आप कंटिन्यूटी चेक कर रहे हैं तो इन पॉइंट पे चेक करेंगे, या अगर आप कंटिन्यूस बना रहे हैं तो इन पॉइंट से बनाएंगे. बाकी में तो वैसे ये पॉलिनोमियल ही है. तो यहाँ पर आप क्या करेंगे, यहाँ पर आप 1 पे भी चेक करेंगे. 1 पे आप लेफ्ट हैंड लिमिट फाइंड करेंगे. यू नो हाउ टू फाइंड इट. तो मैं डायरेक्ट लिख सकता हूँ इसका लेफ्ट हैंड लिमिट 1 पे आएगा -2 ओनली, सॉरी -1 पे, -1 पे चेक करेंगे पहले. तो -1 पे इसका लिमिट आएगा -2 लेफ्ट हैंड लिमिट. -1 पे इसका राइट हैंड कैसे करना है वो मैंने तरीका बता दिया, आपने वैसे स्टेप्स फॉलो करने हैं. यहाँ पे राइट हैंड लिमिट कैसे आएगा, इसका जो राइट हैंड लिमिट है वो आ जाता है -a - b. इन दोनों को इक्वेट करना है तो वी गेट -a - b इज इक्वल टू -2. ये आपके पास एक इक्वेशन आ गया. ठीक है, फिर इसके बाद आप चेक करेंगे इसकी लिमिट्स जो है वो 1 पे. तो 1 पे जो राइट हैंड लिमिट है, लेफ्ट हैंड लिमिट सॉरी, दैट विल बी a - b. जबकि यहां पे राइट हैंड लिमिट जो होगा that will be simply 3. We want this function to be continuous, so a - b should be 3. अब इन दोनों को ऐड करें, adding these together, -a, these are cancel, we get -2b. हम एडिशन कर रहे हैं, ध्यान में रहे, -2b इज इक्वल टू 3 -2 विच इज इक्वल टू 1. ये -2 है, ध्यान में रहे, कंफ्यूज ना हो इसे. तो b इज इक्वल टू -1/2. और इन दोनों को सब्ट्रैक्ट करेंगे तो आपके पास सब्ट्रैक्शन में क्या हो जाएगा, ये दोनों कैंसिल हो जाएंगे एंड वी गेट -2a इज इक्वल टू -5 which gives you a is equal to 5/2.
सर
Yep.
सर ये ए एक्स माइनस बी में तो दो कंडीशन है ना हमारे पास कि एक्स ग्रेटर देन -1 और लेस देन 1, तो इसमें से हम कौन सा कंडीशन कब लेंगे?
देखिए अगर हमें राइट हैंड लिमिट चाहिए तो x ग्रेटर देन -1 होगा ना, -1 पे अगर हमें राइट हैंड लिमिट चाहिए तो ये यूज करेंगे ax माइनस बी, बिकॉज x ग्रेटर देन -1 कहाँ पे है। मैंने क्या कर दिया, मैंने x ग्रेटर देन राइट हैंड लिमिट के लिए मैंने इसको यूज किया, ax माइनस बी को यूज किया। 1 पे लेफ्ट हैंड लिमिट के लिए आप इसको यूज करोगे बिकॉज x लेस देन 1 है। अपनी कंडीशन ये देखना है ना, जब हम लेफ्ट हैंड लिमिट फाइंड करते हैं तो हम कहते हैं x लेस देन -1, तो x लेस देन -1 के लिए ये कंडीशन यूज होगा। फंक्शन ये दिया हुआ है तो मैंने -2 को यूज कर दिया, यू सी दैट। जब मैं राइट हैंड लिमिट फाइंड करूंगा तो मेरे पास x ग्रेटर देन -1 होना चाहिए। अब x ग्रेटर देन -1 कहाँ पे है, वो यहाँ पे है, तो उसके लिए मैंने ax माइनस बी को यूज किया और x को -1 पुट करके मेरे पास -a माइनस बी आ गया। जब मैं 1 पे आ गया तो लेफ्ट हैंड लिमिट पे मेरे पास क्या था, x मस्ट बी लेस देन 1। अब x लेस देन 1 कहाँ पे है, इस इंटरवल में है ना ये, तो आपने इसको यूज करना है। अब मैंने x की जगह 1 पुट किया तो मेरे पास a माइनस बी आ गया। और जब मैं राइट हैंड लिमिट की बात करूंगा तो वहां पे मेरे पास x ग्रेटर देन 1 होगा, और x ग्रेटर देन 1 के लिए फिर कौन सा फंक्शन यूज हो रहा है, वो 3 यूज हो रहा है, तो मैंने 3 को यूज कर दिया। क्लियर?
यस सर क्लियर हो गया।
तो 1 के लिए आप यूज करेंगे, -1 के लिए, दोनों के लिए यूज होगा अकॉर्डिंगली।
ओके
यही
सर।
चीज क्वेश्चन नंबर 46 में भी है, ठीक है। उसमें भी 3 कंडीशन आपको दिए हुए हैं और इसमें 2 कांस्टेंट्स हैं a और b, तो आपने यही तरीका करना है जो मैंने यहाँ पे कर दिया। आप लेफ्ट हैंड लिमिट एट 0, राइट हैंड लिमिट एट 0, लेफ्ट हैंड लिमिट एट 2, राइट हैंड लिमिट एट 2 एज वेल, इक्वेट करें और यहाँ से आपके पास a और b की वैल्यूज आ जाएंगे सारे। ओके, क्लियर द बोर्ड। So let's move to next one। आगे हमारे पास अब डेरिवेटिव्स आ रही हैं, तो डेरिवेटिव्स मैं डिस्कस करूंगा फिर इंशाल्लाह नेक्स्ट लेक्चर में। आपको मैं इसका होमवर्क दे देता हूँ। डेरिवेटिव में 2 चीजें हैं, देयर आर 2 पार्ट्स ऑफ डेरिवेटिव विल बी डिस्कसिंग। वन इज डिफरेंशिएबिलिटी एंड द सेकंड वन इज फाइंडिंग डेरिवेटिव्स। तो फाइंडिंग डेरिवेटिव विल बी योर job, that will be your task, you will do that. So if you move to go to the end of this lecture, the lecture is given at the end. So exercise 3.5, exercise 3.6, exercise 3.7. In 3.5 you have to find derivative of trigonometric functions and you know how to find it. तो exercise आप check कर लें सिर्फ, एंड इफ यू फील कि आपको कुछ प्रॉब्लम है तो 2-3 क्वेश्चंस कर लें उसमें। अगर आपको लगता है कि नहीं मुझे सारे डेरिवेटिव्स आते हैं ट्रिगोनोमेट्रिक फंक्शंस के, तो उसको दोबारा चेक करने की जरूरत नहीं है, एंड इट्स ओके फॉर यू। द सेम थिंग 3.6 इज ऑल अबाउट चेन रूल। आपने एफएससी में किया हुआ है ये, तो आप इसको कर सकते हैं, चेक करें। अगर आपको लगता है कि नहीं मुझे कुछ सवाल में प्रॉब्लम आ रहा है तो वो कर लो, ठीक है। अगर आपको लगता है कि नहीं मुझे आता है सब कुछ, तो दोबारा करने की जरूरत नहीं है। नहीं, ये रिकॉर्डिंग मैं आपको फिर बेचने के लिए मैं बेचूंगा ना, इसलिए मैं रिकॉर्ड कर रहा हूँ कि मैं आपको सेंड करूंगा ना। अगर मेरे पास राइट्स हुए हैं तो आपने मुझसे पहले रिकॉर्डिंग स्टार्ट ना की। ओके, इम्प्लिसिट में भी वही चीज़ है, x स्क्वायर प्लस वाई स्क्वायर इज इक्वल टू 4 है, तो आप इसके डेरिवेटिव लेंगे 2x प्लस 2y dy बाई dx इज इक्वल टू 0 एंड देन यू फाइंड dy बाई dx। तो ये चीज़ आप एफएससी में कर चुके हैं, तो you can do it, right? Check it. If you got any problem, you can discuss with me next lecture. Otherwise, करने की भी जरूरत नहीं है आपको। ऑलरेडी अगर आते हैं तो ठीक है, हो सकता है मैं आपसे सवाल पूछ इसके बारे में, लेकिन एग्जाम में तो now I'm finishing. Turn off the captions, and if you got any question, you can ask me now. I'll share that online, फिर check करें इसको exam policy को. अभी मैं अटेंडेंस लेने वाला, आप लोग इस वक्त छोड़ रहे हैं क्लास को, तो फिर तो मसला हो जाएगा ना.